Okay, so I wasn't having any luck programming it with just a chip. I think I need the crystal for that to work properly. I keep getting a board error telling me that it doesn't recognize the board I'm trying to program it to. So I suspect it's running at the wrong clock speed or something. But we can use this right here, which is a Duo Melanova. Basically, it's a clone, by just pulling the AVR here with this chip puller very gently, straight out. Set it over there where we don't lose it, and then make sure we get this aligned correctly. Very gently. Then we just go 11 to 11 and 12 to 12, 13 to 13, and 10 in this configuration goes to reset on this dummy board over here. Ground to ground, 5 volts to 5 volts. And we need this capacitor still. So let's see what that does. That should work in theory. So I noticed that we don't have a heartbeat here. I pulled the wire. Let's just make sure we have a heartbeat before we go doing anything. Okay, good. Alright, so this is the programmer now, and this is, well, this is the programmer, and this is the programming jig, I guess you could call it. This is a blank 328 chip. So we go to Tools and switch the board over to a Duo Melanova, because that's what this board effectively is, with a 328 chip installed. And then make sure you have the programmer set to Arduino as ISP, and then we should just be able to burn the bootloader. In theory. Yeah, there we go. Bootloader is burning to the board. As you can see over here, lots of activity on the various LEDs. And 13 over here is flashing, indicating that data is coming down the line. And this is going to take a minute, but we'll sit here through it. You can skip forward if you don't want to watch the lights blink for another who knows how long. But here you go. Done burning bootloader, and then it gave me an error about the board not being in sync because I can't reboot this board. And look at that. We now have a blinking 328 with an Arduino bootloader on it, and presumably the blink sketch loaded. So now we should be able to do something fancy here, like pull this completely out, disconnect the Nano. We don't need the Nano anymore. And then move that over here and plug in this little guy directly without breaking it. Alright, now let's see if we can load an example sketch here. Basic blink. You know, let's do fade. Fade is a little more interesting, and it's a little more obvious that it's changed. So we have our fade amount 5, pin 9. This is going to be fading an LED on pin 9. That's not necessarily what I want. So I'm going to change pin 9 to 13. So we happen to have an LED soldered on pin 13 on this board. And I need to change my programmer back to AVR ISP Mark II. Set the serial port to COM4 in this instance. Make sure the board is set to dual melanova. And we're good. Should be able to compile this and upload. See what happens. It's compiling. And uploading. And this probably requires a pulse width modulated output. Indeed. So we've got it blinking on and off. I kind of suspected that might be the case. So let us do something a little more interesting. We're going to go between 9 and 10. Actually, let's do 8 and 9. 8 is not a pulse width modulated output. So switch our pen mode back to 9. And then I'm going to add another pen mode function here and switch 8 to an output as well. And then there is an analog write at the beginning of this. And we're just going to set it to 1. So we're writing a 1 to pin 8 and our 0 to 255 to pin 9. And let's see if that works. So we'll stop blinking here, and then this should start fading, assuming I got the logic correct. Logic is backwards. Yeah, indeed. So there you go. Just took a blank chip, programmed it with a bootloader, wrote a little test program to make sure it works. Now we can pull this chip out of this board completely and build up our circuit here as soon as I get some capacitors. I'm going to order some capacitors for these crystals here shortly. They're cheap. I think 100 of them is $18 from DigiKey. Price has gone up since they have to be lead free now. So that added about 7 cents per capacitor. That's okay, I don't mind that. It's still cheaper to buy 100 of them than it is to buy 2 anywhere else. I mean, you're literally looking at 9 of them from Radio Shack if you were to buy the same capacitor. So it's well worth buying 100 from DigiKey and just dealing with waiting a day or so. And going to build an LED controller, I think. I don't know. I have to talk to some folks and see what they're wanting to do, but I thought I would at least try this. Get used to programming these chips like this. And I'm going to do that a lot more often, I think. Save these boards here, the prototyping boards, for, well, prototyping. And then, you know, either use these breadboards or etch my own boards, whatever the case may be. And not waste these nice prototyping boards on an actual circuit that's going to be permanently in use. Because these boards are expensive and this chip is $3. So you're literally looking at $5 worth of parts, and whatever this board costs, it's a couple dollars. And That's cheaper than $30 for a whole board every time you want to do something. Anyway, thanks for watching. I hope that showed you something useful. And keep looking for more videos. I'm going to try to make them more often now that I have a working camera set up again. Had a little bit of a problem with software there for a while and couldn't make any videos. But hopefully that's resolved. So thanks for watching. Hope you enjoyed.